sort of the revival here. And I guess I'm going to pass it off to Erica.
Thank you, Eric, and thank you, James, it's great to see everybody here. I know we're working on reviving a Ruby meetup that, hasn't been loved for a while, so we're going to help and host a few events there. And then I know a few of you here are also from Eventbrite, so thank you, everyone, for coming. We really do appreciate it. So I want to welcome everyone, obviously, and then with you hit the next slide, we're going to talk about how Valimail is hiring for tech talent in San Francisco. If you also have friends in Seattle, we have a WeWork there as well as in New York, but we're hiring for engineering positions, product, as well as sales. So if any of you are looking for opportunities, please come talk to me. I will be here all night throughout the end of the evening. And of course, if you're looking for anybody, everybody raise your hand here who's here at Valimail, engineer or otherwise. Yeah, so you look around. We've got some people here with Valimail shirts on, but feel free to talk to any of us. If you want to find out more about our culture, our tech stack, anything, definitely let me know if you are looking for opportunities or if you have friends who are looking, and I will help you in every way, shape, and form. Without further ado, it is my absolute pleasure to introduce everyone to our co-founder and CTO, Peter Goldstein.
I'm using this.
Yeah.
All right, can everyone hear me? Yes? We got the mic? All right, I'm going to assume yes. So first off, let me introduce myself. I'm Peter Goldstein. I'm the CTO and co-founder of Valimail. As Erica mentioned, we are hiring, but it's nice to know we do too. So Valimail is an email security company. What we've done is pioneer the use of identity as a source of security in email. Specifically, we've built technology that allows companies to protect their own domains, to ensure that other people can't send on their behalf, and to do that in an automated fashion such that they can get to what we call enforcement, that is blocking that kind of fraudulent use of their domain quickly and easily. And our most recent product is really about guarding from so-called lookalike or untrusted domains by taking advantage of thousands of real-world data sources. We've pulled in information and basically associated domains with real-world entities. We've kind of built the whitelist, if you will, so that we can sell to companies and give them protection against the random domains that are sending them email and basically trying to phish them. And we've got more coming too. So that's what we do. I wanted to introduce that. And as for me, I've been working as a professional software engineer of one form or another for, at this point, 20 years, which is a little disturbing. I've been working with Ruby for about 10 of those 20 years. I have taken roles all across the board: IC, engineering line manager, VP of engineering, and CTO, and of course, co-founder in this case. I also ran a CTO for hire business where I got exposure to a broad breadth of different businesses, which is part of what's informing my emphasis on the build pipeline, right? And so that's what we're here to talk about today. So the first question is why do we need a build pipeline? And the most common answer that you hear is the first one, the velocity answer. It makes you go faster. And that's true. It does make you go faster, and that's really important. Specifically, it protects you against regression. It allows you to rapidly build your artifacts and get things to staging and production. But there are a lot of other reasons that are not as manifestly obvious as the need for speed, right? Security. Sometimes software systems get breached. Sometimes libraries have vulnerabilities. Having a build pipeline makes it possible to quickly and easily remediate security issues. It allows you to quickly go from, hey, we found out about this issue, or hey, this issue has shown up in a library notification, to we have fixed this issue in production. And in modern software, where frankly you're always to some extent under attack, this is a really good idea, right? And having worked in large-scale systems, it also makes it easy to verify the code you've actually got running in production. We have a little bit of an advantage writing Ruby in that our assets are not really compiled. You can go, you think there's a patch, you can go look at the source code, but that's not true for all languages, and it's not true for all pieces of the Rails app necessarily, because you may have libraries that are compiled in, minified, etc. For JavaScript. And so knowing what's on production, knowing that that CVE is not your problem anymore is really important. And a build pipeline gives you the ability to do that with confidence. And that ties to the next point, which is an increasingly important one in today's world. If you had talked to me certainly 20 years ago and even 10 years ago, I would have told you that compliance was a pain. That compliance is really just one of those things you occasionally have to deal with, and I want someone to keep it far away from me. But as I've engaged with larger enterprises, and especially in a world that has things like GDPR in it, where SOC 2 has become, frankly, table stakes for engaging with, as a SaaS, with a whole bunch of enterprise companies, and engaging with the government requires FedRAMP, I can tell you that compliance is actually really important. It's how those entities who are using you have faith that you're doing at least something that looks like the right thing. And so being able to tell them, yes, this is how we handle this kind of problem. Yes, at any time, I can tell you what's in my production environment. I can run that report. I can do this, is super important. And what's more is compliance is largely about process, right? And the need for having to be able to document a process, to explain it to your customers, to your partners, is really important. And so a build pipeline becomes a fundamental piece of that in a way that's not always obvious when you're just trying to get a web application out the door. And the last one of these items is even more, ephemeral. Not ephemeral. It's more abstract. It's the contribution to culture. So we're all Ruby and Rails people. We believe in convention over configuration. I started my career as a Java app developer. I have spent more time arguing over the names of tables than I care to tell you, right? What a build pipeline allows you to do is have your team make decisions about how their code should look, how their code should work, incorporate that into an automated process, and not make it an argument during every code review, right? It's a lot easier to say, well, the lint step failed, than to have a debate over whether or not the brace should be hanging or not, right? And then you can surface these things to the right level, and I'll talk about them a little bit later, but it's really about surfacing those questions, those concerns, those policies to a team discussion outside the context of any individual change, rather than making it a fight every time you want to look at a particular piece of code, right? And that makes your culture, frankly, a lot easier to deal with. Next slide. Good. So the next question becomes, what do we need to support a build pipeline? Because a build pipeline requires a bunch of supporting framework. The first one, which I really hope I don't need to argue with anyone about, is a code repository or a version control system, right? Again, 20 years, I've had more than my share of arguments about why we need CVS, SVN, Git, what have you. Why can't I just keep this in the folder and we'll just keep you up to date? I'm hoping we're past that, right? Right? We like GitHub, we like GitLab, we like all of these things. So, the code repository and the corresponding version controls serve important purposes. They allow the machines that are going to build our artifacts to actually get at the code. And critically, they allow us to produce an attribute. With Git, this is especially easy with the SHA, that's a tag of, this is the state of this source code repository when I built this thing, all right? That's a requirement. You can't have a build pipeline if you can't get at the stuff that is the raw material for your build, and you can't label what your build was. The second thing you need is a build automation framework, right? And I don't really care whether you've got an internal Jenkins cloud that you're managing, or whether you've got using Travis CI or Circle CI, but essentially you need something to run a bunch of tasks. And you need something that can trigger and can receive notifications of, aha, the code repository has been updated, let me execute. There are many good choices in this space. I have some favorites, which I will not share with you, but I am basically you need something, right? You need a notification system, all right? I'm assuming most of you use Slack, right? That kind of fits the bill. There are other options, obviously. You can use email, big fan. But you need a way to know, hey, the builds are failing, right? You need to know, I need to do something about this. And frankly, you also need to know, hey, the builds were a success. Here's this shiny artifact that you can deploy to your production system. And so these, again, is a requirement, right? Just kind of table stakes. The one that I actually feel is missing most often is not any of the first three. Those are technologies. It's a culture that prioritizes automation and testing. I mentioned that I have spent a bit of my career in consulting, and I specifically had a CTO for hire business where I went into organizations and looked for what was not working. The CEO would call me in. And my experience was nothing gave away the problems in an organization as much as their build pipeline and their reaction to it being broken, right? When I went into a company and I said, show me your automated build system, and they happily pulled up a Jenkins console, and I said, the date on this build is 3 months ago. They're like, oh yeah, it's been broken since then, and we don't know why, and we just are we haven't dealt with it. That tells me a lot about how they think about testing, how they think about building software. It tells me a lot about where their priorities are, and it doesn't say very good things. When you're founding a company, when you're joining an engineering team, having a culture that prioritizes testing in the build pipeline, because tests by themselves are not enough. Having a bunch of tests that you can run, even if they're all green, and frankly, I've never seen a situation where the build pipeline was broken and the tests were all green. But even if that were the case, having individual developers have their own view of the state of the state is not an acceptable substitute for having a shared build pipeline where everybody knows what master looks like and everybody knows that it's green. And green goes beyond testing. As I said earlier, it's about, we'll go into the steps of a build pipeline, but it's also about making sure that the code represents the team's standards. And so linting is an important part of it. There are scanning elements. You have to have a culture that says, when the build is broken, the first thing I do is fix the build, right? Everything else has to stop until the build is fixed. Now, the truth is that most of the time, the build will work great. If you don't allow people to merge things that are broken, then most of the time, everything works fine. But sometimes you'll find a library update breaks your build. You'll find that a library that was fine before now has a vulnerability. You'll find that a data source has changed that you're using in your build pipeline. And how you react to those, how you deal with those is super important. Right? Any questions? Sure. Yeah. Right. And I will talk about that in the test step, but yes, that's why I said prioritize testing. So I have there, does the team view writing complete tests as part of their job? And we'll talk a bit about what complete tests should mean, but yes, right? I consider it a real danger sign when I see tests where you can gut the class that you're supposedly testing and everything passes. I wish I could say I didn't see that particularly frequently. It's not about getting the cookie for getting it green. It's about keeping yourself to a certain standard of craftsmanship such that what you're producing, you are willing to stand behind. And that's part of the culture that you built. Any other questions? Great. Next slide. So this is what I would call a typical build pipeline. This is a relatively complete one. It essentially would be one that supports continuous deployment, and it's not unusual for organizations to have a truncated pipeline. I am not sitting here and telling you that day one of your seed startup, you need to have a full CD pipeline all the way through. What I am telling you, and you can kind of see this where the dotted lines go, is you really kind of need the solid lines to be in place first. And then as your maturity level grows, as your confidence in your software grows, you may choose as an organization to roll out those last steps. And I'll talk to you about what some of the decisions might be and why at a certain level of maturity, you might be like, whoa, I don't want to automatically push stuff to production. And past a certain point, you might be, I've got the framework that I have that level of confidence. I'm going to skip really talking about the prepare step because that's really more about the details of whatever automation framework you're using. And I'm going to skip talking about the deploy step too much because that's really much more about the details of where you're deploying. It's those three segments in the middle, that code, build, and verify, that I'm going to talk about. So let's go to the first one. When you are building a build pipeline, it is crucial that the team establish rules for what the code should look like, right? It is important for common ownership. It is important for a team that is willing to dive into different pieces of the code base, that your code have a certain uniformity of look, a certain uniformity of behavior. And the way that you establish that is with whatever linting rules your team signs up for. There is no necessarily best answer here. It is not that there are lots of different choices about Ruby. You can tune your Rubocop configuration to do whatever you like. You can say, I don't want something that's tunable, give me standard RB and I'll take it. But at the end of the day, the important thing is that whatever those standards are, they have to be in place and your team has to buy into them. That also means your team should have the ability to change them, but not to change them in response to a single pull request or a single change, but by having an actual discussion of what that change will mean across the whole code base, and in many cases across all code bases. My experience has been organizations work best when we establish a set of standards for each language, not necessarily for each project. And that's generally what I try and encourage my teams to aim for. Now, that all said, there are times we need to override the linter, right? It's not, it's not necessarily a desirable state, but for example, if you've got a method that's exceeding whatever your complexity bounds are, if you've got a wacky string that you've got to include and like loading that entire cert into the file means you're going to run into a complaint from your linter, that's okay too. The purpose of this is not to put you in a straitjacket as a team. The purpose of this is to make sure that decisions are not made unilaterally by a single team member. And so as long as when you do those overrides, they're part of the discussion in the code review, then you have a meaningful conversation. You also want to commit as a team, ideally, to reviewing these, not often, but definitely not leaving them for 9 months, 12 months, 18 months, and making decisions where if you see enough of these overrides on overriding the same thing, maybe it's time for the team to discuss changing whatever standard you're having to override. Right? Are we getting a glare? The view has some downsides. All right? And then finally, you really want to make linting as easy as possible. In general, what you want is client-side tools that run whatever your linter is, because having done it enough times, doing a commit that looks fine, that then runs into linting problems only on the repo is annoying. And so it's generally pretty easy to configure your Git hooks to run quickly, whatever lint tools you have, and to mimic at least the core of whatever lint step you've got. No worries. Does that make sense to everyone? Great. Next slide. Next slide. Cool. So let's talk about testing. Again, I'm very happy that what I'm going to talk about, I hope, is not too controversial, because I do remember when it was. It is very important to try and get high coverage on your code tests. And by high coverage, I don't necessarily mean, oh, I've got 95% lines of code coverage. As we were discussing earlier, that's not really enough. The team needs to be committed to covering branches. The team needs to really be able to stand behind and say, I've committed this, I've got tests on it, I know its behavior is going to work, right? That needs to be part of the equation. And you don't, like, yes, you should have a code coverage tool, but the truth of the matter is that that code coverage tool will not necessarily tell you when you're in trouble here. Part of what you need to do is look through the specs, make sure you've got coverage, make sure you have agreed upon guidelines of what good test coverage looks like, and especially when you're looking at unit tests, go, hey, what's the contract for this thing? You're adding a new class. Have you covered the key cases? Oh, we're expanding this capability. Have we covered the variations? Because that's where you get the true safety net. That's where you get the true speed bump to your development velocity, because now you're effectively protected against regression. This is a Ruby meetup, but I haven't seen a Ruby app that's just Ruby in at least a little while. I think the odds are pretty high you've got JavaScript in your app, right? And so you want to test the JavaScript too, right? So if you have other languages that are part of your stack, part of your packaging, it's crucial to cover all of them, right? It just needs to be part of your flow and integrate it, right? Speaking of integrate, let's talk about unit versus integration testing. So people tend to have strong opinions on which one is better, right? And I have my opinions about which ones are more essential. But the truth of the matter is that certainly once you reach a certain point of maturity, you need to have both. The unit tests give you breadth. They allow you to test all the combinatorics that if you attempted to test with an integration test or a set of integration tests, your test would run for days, right? You just have these little Legos, you test the behavior of the Lego, you get a lot of confidence in the behavior of the Lego, and you're good. But you also need an end-to-end test. You need an integration test that's going to do A to B and kind of give you coverage there. Because again, you can have your Legos all work well, but they're not plugged into each other in the right way, and your unit tests probably aren't going to tell you that. So that combination of both is important, and it will depend on the maturity level of your team, what precisely you're doing, what balance is right for you. And finally, one of the things that I see often left out, but I think is really important and frankly a lot easier to do nowadays than it once was, is visual testing. There are services out there that are easy to plug into a build pipeline, and being able to demonstrate that your app produces, if what you're testing is a web application, it produces the web pages you're expecting to see, is really important. You know, to some extent, I can tell you this, speaking of myself as a developer, I tend to underemphasize the importance of the appearance of the application. I tend to think more about, oh, is it doing what I expect it to in the back end? Is it queuing the right sidekick job? Is it creating the right models? Is it doing the right thing? But the visual interface is how most of your customers will interact with your application. And so you really care if it breaks. And so to bring proper value to your customers, you should be watching that. And it's a lot cheaper to do that with any of a dozen services that are out there than to hire a bunch of QA engineers to sit in your office and basically walk through scripts, right? Or to write their own. Okay. Any questions about that before I go on? Great. Next slide. So, scan. And this is a step that often gets left out, frankly, in its entirety. You know, as the co-founder of a security company, I take security relatively seriously. I think that anyone who's read the news about God knows how many application breaches, issues where libraries weren't up to date, right, Equifax and all the rest, should really understand that in 2019, part of a developer's job, part of an engineering team's job has to be security. No one's asking your average developer to be a cryptographer. That would be a terrible idea, all right? No one's asking you to redesign SSL. We saw what happened with that with Heartbleed. We want to avoid those sort of things. But that doesn't mean there aren't tools that you can use to scan your application and make sure that you're not inadvertently introducing security vulnerabilities into the applications you build, right? These basically fall in two big classes, at least at the code level. One is auditing your dependencies. So you should know if your libraries have a CVE, right? You should know really quickly, and you should do something about it. The other is static analysis. So static analysis tools vary in quality and importance, but that's another option you can use to take a look at your code base and figure out, are you doing anything you really shouldn't be doing, right? Something like Brakeman, other options. Now, in addition to security questions, the business may have a few things that it has to say about your code base. Anyone who has ever been through a Series A, B, etc. fundraise knows the joy of doing a license audit against your software and having to explain any presence of the GPL in your dependencies, right? Many businesses have therefore decided it's way easier to avoid including these things than have those conversations. You may have other restrictions related to licensing. There may simply be certain licenses you're not permitted to use. There may be certain libraries for a variety of reasons that you are not allowed to depend on. There can even be functional requirements. For example, let's say you've got a system that you need to maintain a certain level of white label capability, which means that you're not hard coding certain terms anywhere in your application. An easy thing to make part of the scan step is to actually put a bunch of strings that you scan for in your locales directory, right? So let's say I'm white labeling, I've got a system where I don't want to encode my company name anywhere. I scan for Valimail in the config locale, for example. Those are things that go in this step and are actually really useful for checking against these kind of regressions. You also see stuff like the IETN tasks has a bunch of tasks that are useful, again, in this phase to ensure you're doing the right thing with internationalization. Finally, I've mentioned compliance once. I'm going to talk about it a few more times during this talk. But one of the things that people who do compliance like is they like records, right? They like to see the results of things. And so if you can say, yes, every time my build runs, we scan and we produce this output, and this output is captured, and it's now in some S3 bucket somewhere, that's a potentially useful thing to add as part of your process, especially if you're shooting for more aggressive compliance regimes. So something like FedRAMP. Any questions there? Fantastic. Next slide. All right, so that's basically the code phase, the 3 steps that generally run in parallel or in sequence, but are effectively that first chunk. At the end of that phase, when you're done with code, what you're saying is, my code is good enough that it can be made into an artifact, right? I'm happy with it, it's all good. And so the build step is all about creating that artifact. And probably the most important thing is to engage in a deterministic process to build reproducible builds. Your build artifact may be any number of things. It could be a binary, it could be a package, you could have a zip file that basically you have an unzip process as part of your deploy. It could be an AMI. So for example, here, when we build Ruby apps, what we do is our Ruby applications build a variety of AMIs that are the output, and then we use Terraform to actually deploy those into our environments, right? So artifact is not a bunch of code, it's a bunch of code running on OS and a stack and a whole bunch of dependencies and files and things like that. So in order to establish a deterministic process, it's important to use a tool set that supports a degree of determinism. I'm a fan of Ansible. Salt is great, Chef is great. There are all sorts of systems. If you must, write a bunch of build scripts, right? But know what you're writing, have it be in version control, and therefore have it be versioned, right? Once you've done that, you really want to tag your artifacts with metadata. At a minimum, you want to tag them with something that says, this was the code that went into creating this artifact. In the ideal case, you've tagged everything. You're like, this is the code, this is the recipe, the deterministic recipe, this was the state of certain dependencies. So you get a bunch of metadata on your artifact that says, aha, this is what we've got. And that allows you to look at that artifact later when it's in production, when you're, 3 days later after you've had a bunch of fire alarms, you've done a bunch of things, you're like, aha, that's right, that's this. That ability to tie back to your code, tie back to your process is really important because it's, again, how you know what you're actually running in production. Now, one of the real negatives of building a build pipeline is there's a strong tendency to have artifact explosion, right? What happened is you wind up, for example, we build AMIs. We build a lot of AMIs. We build thousands of AMIs. Something has to clean up those AMIs or you start getting charged money for those AMIs, right? So you really have to think carefully about how you're managing the output artifacts process. How do you minimize what you're creating, right? So for example, in our build process, we only execute the build step for things that are on master. So when master gets an update, we run everything prior to build on everything, any code branch, any commit. But it's only when you merge to master or when you use a special tag that you actually get an artifact popped out, right? Because otherwise we'd have a lot more artifacts. Similarly, you should have a system for cleaning up those artifacts, understanding what's obsolete, figuring out that you're not paying for storage for these things. In some cases, this matters a lot. In some cases, it doesn't matter too much. But in all cases, it winds up being kind of a management headache if you have too many of these artifacts laying around. Does it all make sense? Fantastic. Let's talk about the next step. So, once you have an artifact, what can you do with it, right? And so this is where you start running to a higher level of maturity, is actually testing the artifact in an environment. Usually this involves, this is often a prerequisite for really doing continuous deployment. I have an artifact that comes out of my build pipeline. I'm going to deploy it to some sort of test environment. That test environment is going to look a lot like my production environment, maybe scaled down a bit, but it's going to have the databases that I'm accessing in a realistic way. It's going to have the network that I'm going to be embedded in a realistic way. And then I'm going to run a bunch of tests, right? And that allows me to certify, oh, this is legit, right? In less mature pipelines where you're not doing continuous deployment, frankly, you usually do this by manual verification, right? I produce an output, I know what changed in it, I deploy it to a staging environment, I bang on the relevant things, everything looks fine, great, let's push it to production. And honestly, depending on your maturity level, that may be totally fine, right? This is one of those things where you really have to make an evaluation as an engineering executive, as a team lead. Where are you on that spectrum of being able to support and manage this kind of framework? Can you manage an independent testing environment, keep it up to date? Have you reached enough maturity to be able to bake that in? And therefore, should you do that? Okay. The other big challenge here tends to be tools to properly simulate, clone, reset the environment. So there are a bunch of different ways to do this. Some of them are easier with things like containerization, some of them are not. But having those tools, understanding what you've got is important. Okay. Next. And then finally, we have yet another scan. Because once you've built an artifact, very often that artifact is something that also needs to be scanned. I will tell you that when we build our pipeline, it is not uncommon for the code scan to be fine and the artifact scan to fail. Why? Because the vols database, which scans for vulnerabilities across all of our OS dependencies, is updated. It's got a new CVE, and the thing we're building has an outdated package, for example. So scanning your artifact is important. And it'll help you discover the things that are all the way up and down your stack that are potential vulnerabilities. Now, it doesn't make sense in all cases. Like, for example, if you're running you're basically running if you're outputting something that is essentially indistinguishable from your code. So the example I've got up here is like a Lambda package, you're generating a zip file, then it may not be useful to scan it per se, because basically it's got whatever's in your code. So you've already done the vulnerability scanning you're realistically going to do. But in cases where you're actually producing a box or an image of a box, this is really important, and it's especially important to the compliance regimes. So I said I would talk about compliance a couple times. This is another place that I'm going to talk about it, because especially since compliance regimes are often, they don't necessarily know what the cloud is. They may be thinking of a world of hosted servers, etc. They want to know things like, hey, how often do you virus scan your boxes? And you're like, my boxes tend to last 3 days. And they're like, so you scan them once a month? And you're like, no, they tend to last 3 days. It's good to be able to say them, but we scan them every time we roll out when we build the box. They're like, okay, I can understand that, right? But again, you probably want to, if you're holding yourself to a significant compliance regime, this can be an issue, and it's often useful to store these scans for precisely that reason. So that's the review of the middle 3 tiers. Any questions? So load testing is typically something I would put into the artifact scanning part, right? So deploying it in a simulated environment is deploying it in an environment that's going to match your load. And so again, when you're at a lower stage of maturity, typically you do that manually. If you're doing something that potentially alters your load characteristics, or you think is going to alter your load characteristics, you might manually run a load test using AB or something in your environment, right? As you get to a higher level of maturity, that just becomes part of your acceptance test. But that's a good point. Any other questions? Hmm? Hmm? So, yeah, so as a general rule, I didn't talk too much about configuration injection and how that really works. But in today's world, I would not generally have a build pipeline that encodes host names, for example, as a general rule. Those would be pulled out of the environments in which it's built. So what you're really testing when you inject that artifact into the environment is, does it look in the right place for the host name that it's expecting to use for X? And then does it connect to do the Y using that host name? And so the fact that those host names may not be the same between your staging environment and production environment is probably not significant. Now, there are times that can bite you, for example, with certificates. But again, most of the time, this is going to be an injected environmental sort of thing. All right? Any other question? Good. So I do have one more thing, right, as the slide says, that I think is separate from the build pipeline, but is something that is really important that can further amplify the value of having an automated build pipeline. Next slide. And that's automated dependency updates. If you speak to anyone who works on the team here at Valimail, they will tell you that I am ridiculously passionate about dependency updates, right? That I think one of the primary dangers for Rails apps, I hear it from at the CTO Club, I hear it from others, is getting trapped on old versions, right? And the work of doing dependency updates tends to be boring, it's not sexy, and you're like, oh, I don't want to deal with this. Well, if your build pipeline is really complete, if you have faith in the artifact that's coming out, then essentially a dependency update becomes a lot less expensive. Because if you do the dependency update against what you were doing and everything passes, you're in great shape. And so when you combine that with robots, there's one I happen to like in particular, that will basically open pull requests for you to update your versions, then you can very, very quickly manage to keep yourself up at some comfortable level that's close to the edge, right? And you may choose, hey, I'm not going to roll out to the latest Rails version until it's got a patch or two, and that's fine. You may choose, oh, devise, they rolled out a new major version, I'll hold it back. But having the tooling that can handle that patch updates for you in an automated manner, even the minor updates, something that gives you the ability to quickly take a look at a dependency update and go, yep, this looks safe, I'm going to include it, update it, done. Why is that so important? Let me explain. One of the most common problems for apps is they get caught with some old dependency that tie them to a bunch of, frankly, unmaintained branches of library. Anyone who's been stuck on an old major version of Rails has had this experience where you didn't do your dependency updates, you didn't invest in that upgrade to Rails 4 or whatever it was, and you're sitting there 6 months later and you're looking at all your dependencies and you're like, okay, what would have been a 2-day, 3-day project is now this thing where this thing's been deprecated. I need to figure out how to replace it in its entirety. We have to make all of these adjustments. All of these minor version things didn't get carried over. Your risk level goes up dramatically. The time it takes to do the update goes up dramatically. And what a build pipeline allows you to do is to solve that problem by doing it as you go, right? Eating those little bits of pain where, yeah, okay, now I'm getting a deprecation warning I need to fix. Or, oh, this version has a change where the interface has changed a bit, so I got to make an adjustment, is a lot easier to do piece by piece as it comes up than to do in one big chunk. And specifically, it massively de-risks it. The other big reason to stay close to, at least in supported versions, is security. So as I alluded to earlier, one of the advantages of a build pipeline is for security and your ability to roll out security patches. Not a big secret, once you get past a certain version back, people don't roll out security patches. Not in a timely fashion, maybe not ever. And so if you keep your dependency updates, you keep your dependencies up to date, you have the ability to take advantage of the latest and greatest security patches, and therefore you can react the way you need to as a professional software development team. Any questions about that? Well, that's all I got. Happy to take any final questions.
Updates. What do you do if you have like an update of a dependency that breaks stuff and you have to like freeze it to a specific version? How do you get rid of this freeze?
Yeah, so that's actually a really good question. So again, similar to what I talked about with the team and linting, what you want is that to be a choice for the team. So there are basically a couple different ways that can play out. One, it could be that updating to that version requires some development work in order to allow you to get to that version. Anyone who's dealt with updates of Rubocop tends to run into this fairly frequently, in which case you make the choice about whether you're going to do that work or not based on how big you think it is. Another is that the new version is broken. It has an error, it's introduced something that shows up as a regression in your test suite, or even it's something that didn't show up as a regression in your test suite and you didn't find because your test suite, for whatever reason, didn't cover it until it gets to production. And again, that's something where you make a choice. You have it, and you basically say, I'm going to lock this to the old version. And as someone who is an open source committer, I'm the maintainer of the Dolly gem. I'm a big believer in contributing back to open source. I actually think the most responsible thing for engineering organizations to generally do is to try and identify the source of the problem that they're seeing, the regression, and commit a patch. And sometimes that patch will get accepted, sometimes it won't get accepted, sometimes another patch that fixes the issue will get accepted. But I think that's part of being that's essentially the flip side of the enormous benefit that we gain from using open source libraries is a degree of obligation in contributing back when we encounter problems. Any other questions? Well,
Yeah, I have a question. I was just wondering if you could explain what is Ruby on Rails? I work in HR here.
Thanks, Liz.
Sorry, that wasn't a real question. You did
okay. Oh, thank you. Yeah. Sure. So the question was, what tools would you recommend for scanning and artifacts? I kind of alluded to vols, and I don't know if I'd recommend vols, but it is a choice. There are also a bunch of companies out there that sell commercial solutions to do various types of scanning. I wouldn't necessarily, your budget helps determine what's available to you as well as what you're going to and quality of item. I think Vols is probably one of your dominant open source choices. It will give you CVEs in your underlying OS. It'll give you CVEs in your packages. It'll basically tell you, and it will output data that is accepted by most of the entities who would potentially audit you, which is a significant advantage. Again, those commercial products are out there, and you can go use one of them, and part of what they sell is that same sort of compliance. Any other questions?
This is regarding quality testing. For example, if you have a function that calls on 2 or 3 other functions, right? Maybe affect the database or make API calls. So one trend is just to test the logic of that function and mock the other ones. And the other one is do a kind of small full integration test. So in your experience, which is the one cheapest way to do that?
There's no question the unit test is cheaper. And the question is, what are you trying to do? And I mentioned earlier that there's a balance you choose between unit testing and integration testing. And what I would say is, as a smaller company, as a more earlier stage company, you're going to tend to bias towards more unit tests for cases like that. Because really the way you want to solve that problem is not even an integration test at the code level. What you really want to do is have that be an artifact test. What you're describing is an interaction with real entities. And so it's, I can spend a lot of time and effort setting up an S3 in my code test to do this, and I can have library, et cetera, but it's a lot more realistic and it's a lot more effective if I do that at the artifact testing phase, where I just make that one of the things that gets tested when I roll out my artifact in my simulated environment, right? And so I think the right answer, as with a lot of these questions, there's not necessarily a one right answer. It depends on your team size. It depends on the maturity of your level of testing. Frankly, it depends on how bad is it if something goes wrong, right? So, the reality is if you've got a process that's talking to S3 or some other external resource, and if it fails, it's not that big a deal, and you can roll out a new version and all of that, that might be less critical to test than, oh my God, this thing failed, and my primary workflows all stop. And those are partially judgments of the engineering team and are part of the time trade-offs you make when you're figuring out what level of coverage you need. Any other questions?
Thanks. Any recommendations for someone working with, I have an API that does a lot of interactions with single page apps or different clients like Swift clients. My API does a lot of these build and pipeline steps that you mentioned, but how can we is there any recommendation for getting the iOS artifacts and the Swift folks sort of into
So
this mentality?
there are actually commercial entities that will run kind of, if depending on what you're using. So for example, if you have a Swift a Swift client application, let's say you've got a client SDK, what you can do is in some of these automated testing, they have solutions where you can drive that device against the API as part of your acceptance test. And that's probably my best solution. Frankly, I got to be honest, I haven't done that kind of work in a little bit, so I'm not the right expert on that.
Fair enough. Yeah. I think Appium is one solution I've used before, but yeah.
Okay.
Thanks.
Great.
Anything? Oh no, good. So yeah, you showed us earlier like some of the build pipelines that you have, and I think the last step was, I mean, obviously the delivery, and I wanted to know like how comfortable are you in terms of like continuous delivery actually?
And it really, this is another one that really depends, right? So part of it is what are you delivering as your final artifact? What comfort level do you have with the test pipeline you've built out? And this is another one of those maturity questions. So to be candid, at Valimail, we don't yet use continuous delivery. The reasons for that really, and that's a discussion, frankly, that we're revisiting right now, because we've hit that maturity inflection point where we believe that it is now possible for us to properly do artifact testing and go to that next stage, while feeling comfortable about the SLAs that we're making to our customers, the kind of critical infrastructure we need to support. If, you know, having made this decision, you know, 3+ years ago, the reason I made it then, if I were in the same state where it's just me, I would make the same decision. I'm going to be really conservative about heading something out the door because I haven't built up enough of the infrastructure. I think that there's a judgment call with maturity with a lot of this, and that's kind of why I see it evolving from, you know, you really start going from the the left-hand side of that diagram to the right, as you get mature as a company, as you wind up having more people who can own more things, as you know, just like you gain a tremendous amount from open source software and the like, the people you hire and the things they do build up capabilities that make it a lot easier to do CD as you get more mature. And I think that every company, whether or not it hits that rightmost point, should really be thinking about how do they get a little bit farther over at each stage.
Makes sense. Thank you.
Yeah, sure. Any other questions? All right. Well, I hope you enjoyed. Thank you so much.